Hello everyone, today I'm going to solve LeetCode problem number 206, reverse linked list. So this is an easy problem. Given the head of a singly linked list, reverse the list and return the reverse list. So let's look at the example. We have an example linked list of 1, 2, 3, 4, 5. So we need to reverse this linked list such that the head, the last node is the new head of the reversed linked list, so that we need to have like 5 4 3 2 1. So this would be our result. So we can solve this problem using two different approaches. There is an iterative approach and the recursive approach. So in this video I'm going to explain about a recursive approach. So we are trying to solve this problem using recursion. So whenever we are thinking about solving the problem with recursion, we need to think about breaking the problem, right? So this is an example linked list 1 2 3, and we need to get the reverse of this linked list, which would be 3 2 1. So when we think about breaking the problem, let's think about first finding the reverse of the remaining of the linked list except the uh, first one. So except one, right? So uh, again again we can think about, so in the second part, so this would be our head, and we need to find the recursion of the rest, sorry, reverse of the rest except the head, right? So here we have three. So but there is no any next pointer towards three, right? So that means if there is no next, then we can simply return the node, right? So that means here we will have the result 3, right? So whenever we have only one node in the linked list, we can simply return that node, right? So if we had only one node, let's say 3, then what would be the reverse of this? It would simply be 3, right? So yeah, that would be the best case. That is the best case in the scenario. So yes, so we have 3, right? Okay. So let me clear this out. So when we have the result of this, now we need to find the reverse of this whole, right? So what we want to do here is, so the results would be like, we need to add the head to uh in the tail of the result of this one, right? Yes. So that means we need to have reference to this 3, because we need to add 2 in the next of 3, right? So that means we need to have reference to 3, and and we need to have this 2 as well, right? So we need to have head as well, right? Because we need to add this 2 in the next of 3. So that means first we need to have reference pointing to 3, and then we also need to have 2, right? So then here we have head, here our head is 2, right? So right now the head 2 has a pointer to 3, right? But we want to we want to break this link, because we want 3 to point towards 2, not 2 pointing towards 3, right? So yes, we need to break this link. But before breaking this link, we need to have reference to this 3, right? So we need to have reference to 3, because we need to add 2 in the next of 3. So that means before breaking this link, so what we need to do, we need to store or get the reference of this 3. So that means we have a node, and we store the reference of 3 here. That means, so here we have our head 2, so head dot next, right? So here, so this L stores the has the reference to 3, right? Yes. Then we have this 2, right? So this is our head. So we want to break this link. So how we do that? Head dot next. So our next step would be to assign null, right? So when we do this, we broke this link. Head, so we have head here, and head dot next equals to null. That means we break this link, that is the 2 is no longer pointing to 3, right? Yes, but we have reference to 3 here, right? And we just have head, right? And head, where the head dot next equals to null, and we want to add this head in the next of 3. So we have this 3 here, L, right? So then what would be our next step? So next dot next equals head, right? So when we did this, we had 2 and I'm sorry, 2 and no, I'm just writing here and for now. Yes, so 2 null, right? So now we want to add this to the next of 3, right? So that means how we did next dot next equals to head, right? So when we do this, so we have 2 and null, right? So that means up until up to here we found the reverse of the remaining of the linked list. So as we did with the 2, we're going to follow the same thing with the 1, right? So in this way we can solve the problem using recursion. So now let's code with the same logic here. So first thing that we need to do is check if head equals to null or head dot next equals to null. We return head, right? So this is our best case. So now we recursively call the reverse list with head dot next here, right? And then what we do here, so here what we did, we store the reference of the head dot next, right? So yes, first list next equals to head dot next, right? And then we broke the link, right? And then what we did, we add dot next, we broke the link here, and then we assigned the next to the head. So here we have next dot next, because this next has the reference to head dot next, right? So that's why next dot next equals to head. Yes, and then now we return new head. Now let's check our code. Yeah, we're done.